So we will look into the encoder. Encoder. For everything the basis is multiplexer. From the multiplexer we got demultiplexer. From the multiplexer all are variants of multiplexer. How it is we will look into it. Even the encoder. Okay. So if I look at the multiplexer, 2 power n is to 1, n selection lines, only one output, 2 power n inputs. This line is 2 power n minus 1, this is 0. If I flip it, 1 input, 2 power n outputs, 1 is to 2 power n selection lines. N selection lines, 1 input, there will be 2 power n outputs. These are 2 power n output lines. Now what I do is, these selection lines I will keep it in the front. These, what are the selection lines are there? Yes, I am changing it, only orientation I am changing. So putting selection lines over here, I will put it here, n selection lines, n inputs, 2 power n outputs. If I do that, 2 power n outputs. Okay, there will be one enable input, if at all you have. For multiplexer we can have one enable, right? Multiplexer we have an enable, right? So we are continuing with the enable. Then it is n is to 2 power n. No more selection lines. This is decoder. From where we got it? From multiplexer itself. What we did? Whatever we are calling as selection lines, we are putting at the front. Okay. So what exactly? From demultiplexer, if you observe here, this input is made as an enable. These selection lines made as inputs. Outputs are same. From where we got this? Demux. From demux, whatever we have written here, we have derived from the mux itself. So what is there in the mux? In the mux, 2 power n inputs, 1 output, n selection lines. With respect to inputs, if you see, number of inputs are 4, number of outputs are 2 power n, number of outputs are 2 power n. Okay, that is the reason why your demultiplexer, decoder are same, they are only different forms. Later on you will see, okay, regarding decoder. Now if I flip it, what is that? Output become, if I flip it, outputs becomes inputs, inputs becomes output. If I do that, what exactly the case? That is nothing but your encoder. Okay, enable may be there, may not be there. So I will be having 2 power n inputs, 0, 1, dash 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 2 power n minus 1. Then n outputs. Okay, there will be n outputs. How many inputs? 2 power n inputs. Okay, so we call it as 2 power n is to n. It is a circuit which is having 2 power n inputs, n outputs, is known as encoder. What we need to do? In order to understand this circuit, what I need to do? I need to understand input-output relations. What is that called? Truth table. From truth table, what we try to do? We try to design encoder. What is meant by design? If I want to design this, what is meant by designing of encoder? To carry out any design, I need input-output details. From the truth table, I write outputs as a function of inputs. From there I will get expressions. From there I will get the circuit. Okay. So now look into it. Let us explore truth table of encoder. Now here is the encoder diagram. We will look into the truth table. We will complete the design. For that, what is required? Encoder truth table. Okay. So I am taking encoder without enable. If you want, you can take with enable. no issue. How many inputs? 2 power n inputs. Let's say, as an example, if I take n is equal to 3, what is it will become? 2 power 3 is to 3. So 8 to 3 line encoder. 8 to 3 line I call it as 8 inputs I0, I1, I2 dash 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 up to I7. I am getting outputs Y0, Y1, Y2. Let's represent inputs and outputs and look at the operation. I1, I2, I3, I4, I5, I6 and I7. What are these? These are inputs. How many outputs? Only 3 outputs. What are they? Y0, Y1, Y2. Okay. So if the input is, let's say, 1 0 0 0 0 0 0, there is a data on line 0. What is the data here? What exactly this will happen is Y0 becomes 1, rest becomes Y0 becomes, let's say everything is 0, output is 0. Let's say this 1 0 0 0 0 0 0, I0 is 0, Y0 becomes 1. So let me write this in the other order so that you can understand well. 0 1 2. So for this is 0 0 1. If I make 0, still it will be 0. This is the issue in this. For 0 1 0 0 0 0 0 0, this will be 0 0 1. Okay. If the 0 0 1 0 0 0 0, that will be 0 1 0. Y2 is 1, output is 2. Y3 is 1, Y3 is 1, output is 3. 3 is 0 1 1. 0 0 0 0 1 0 0 0, output is 4, because data line is Y4 is 1. Okay. So 0 0 0 0 0 1 0 0, output is 1 0 1. Next 0 0 0 0 0 0 1 0, output is 1 1 0. Next 0 0 0 0 0 0 0 0 1, output is 1 1 1. It is called encoding. What is encoding? Wherever is input line is activated, if particular input line is activated, what exactly the line that is being activated is showing at the output. For example, Y4 is equal to 1. When Y4 is equal to 1, it is showing output as 4. How I get output as 4? What is the value of this? 4 only. How do I know that? 2 power 0, 2 power 1, 2 power 1, 2 power 2. 2 power 0 multiplied by 0, 2 power 1 multiplied by 0, 2 power 2 is 4. Generally, to get the value of a binary number, you have to write the weights. What exactly the weights? 1, 2, 4. If I write 1 1 1, 4 plus 2 plus 1. If I write 1 0 1, 4 plus 1, 5. If I write 1 0 0, it is 4 only. If I write 0 1 1, 2 plus 1, what I am doing? 1 1, under 2 and 1, 2 plus 1, 3. Likewise, you should be able to find a value for a 3-bit binary number. So what exactly the operation? This is what exactly the operation described. Okay. From this, what exactly we need to do? We need to look at the design. What is meant by design? What is meant by design is, what is this box actually? What is there inside? Such that this operation is taking place. So there is something inside this box which is in a hardware, which is made of logic gates or combination of logics, because of which this particular operation is going on. So to carry out this operation, what exactly we need to do is, we need to write expression for y0. y0 is function of I0 to I7. Y1 is also a function of same. Y2 is also a function of the same. Right? So, what is the expression for Y0? When Y0 will be 1? Y0 is 1. Y0 is 1 here, 1 here, 1 here and 1 here. So 1 it is at I1, or this is for I3, or it is for I5 plus I7. Just ORing of I1, I3, I5 and I7 will give you Y0. What about Y1? When Y1 is 1, 1 here, 1 here, 1 here and 1 here. 1 is for I2, then I3. So I2 plus I3 plus what exactly? This is 6 and 7. So I6 plus I7. Next, what is Y2? What is Y2? Is 1 here, 1 here, 1 here, 1 here. From this, look at the inputs for which they are 1. So is it not I4 plus I5 plus I6 plus I7? I can get Y2 from I4 plus I5 plus I6 plus I7. What is the meaning of this? Use, so the overall this block is nothing but 4 OR gates. What are they? I have an OR gate, only 3 OR gates with 4 inputs, okay. Then I am going to get my outputs Y0, Y1, Y2. What are the inputs to them? This is I1, I3, I5, I7. What about this? I2, I3, I6, I7. What about this? I4, I5, I6, I7. So this is what exactly is encoder. Design is complete. Whatever the block that we are referring to is going to contain these set of logic gates. Inputs, outputs. This box is this hardware. For this circuit we have a couple of issues. We will look into it, then we will see what is the solution for it. The couple of issues are, when all inputs are 0, output is 0. When one of the input I0 is 1, also output is 0. This is an issue. If you are getting output 0, whether I0 is 1 or I0 is 0, in a question mark. Next, at any instant of time, if only one line is high, we have seen the table, this is how it is going to function. But for example, if I3 is 1 and I6 is also 1, what will be the output as per the equations? Rest all are zeros. I3 is 1, I6 is 1, rest all are zeros. I3 is present, 1 plus something, 1 only. So Y0 will be 1. What about Y1? I3 is there, I6 is there, 1 plus 1, ORing, 1 only. Doesn't matter I2, doesn't matter I7, whether they are 1 or 0, I will get a Y1 also 1. What is the Y2 value? I6 is 1, so I6 is there. Doesn't matter whatever those values are. If 1 is odd with something, I will get 1 as an output. Okay. So y2 is 1. What exactly it is saying? 1 1 1 is saying I7 is 1. But what exactly the meaning here? Actually I3 is 1, I6 is 1. But what your circuit is saying is I7 is 1. Okay. Why is there is no certain priority to the inputs? To solve this problem, we will go for priority encoder. We will give priority to the inputs. Here there is no priority, simply inputs are there, only one input is there, it works properly. If more than one inputs are there, we need to give a priority to the input so that it works properly. To solve this issue, we go for priority encoder. Okay, with this I will stop. Okay, stop it.